Welcome to the first and last video presented to you by Savvy Science. The topic for today is distributing heat. Well, for oceans at least. First, let's start by analyzing water. Water has a large heat capacity and absorbs more than 90% of the solar energy that strikes it. Did you know oceans cover about 70% of the Earth's surface and have a very large volume? Energy absorbed by water is distributed throughout a greater depth than on land. Pretty crazy. Once heated at the surface of the oceans, the water can be mixed downward by waves, turbulence, and subsiding currents, so the heat does travel downward. Solar energy absorbed by the oceans is distributed by complex patterns of currents, which are caused by surface winds, the water's salinity and heat content, and the contours of the ocean's bottom. Next, let's talk about the effect of ocean currents on climate. Ocean currents have a big effect on weather climate in coastal areas and influence worldwide climate. Gulf Stream is a large surface current that starts in the warm, shallow seas of the Caribbean. It follows the eastern coastline of the US and Canada, curving east just south of Newfoundland, ending up near the British Isles, where it's called the North Atlantic Drift. When the Gulf Stream water reaches North Carolina, it is warmer than surrounding water, making the air above the current warmer than the air on either side. The air contains more water vapor, sometimes creating dense fogs. Oceans are considered heat reservoirs for the entire planet because they change temperature much slowly than the atmosphere or the land. Gulf Stream is actually a part of a global current called thermohaline circulation of the Great Ocean Conveyor Belt, discovered in the 1990s. Next, we're going to talk about El Niño and La Niña. El Niño is Spanish for little boy, which was first used by fishers to describe the warmer waters that occur in late December off the west coast of South America. La Niña, or little girl, is the opposite of El Niño, characterized by an increase in the strength of the normal patterns of westward moving winds. Let's talk about El Niño. El Niño is a distribution of an ocean atmosphere system in the tropical Pacific that occurs every 3 to 7 years. During an El Niño year, the wind direction over the South Pacific reverses and the winds flow eastward. This causes an increase in the sea surface temperature in the eastern equatorial Pacific Ocean. This change causes heavy rain over the west coast of South America and drought conditions in Southeast Asia and northern Australia. It is unknown why the winds reverse direction. El Niño can also affect weather patterns across 25% of the Earth's surface and is believed to be responsible for many unusual weather conditions. It produces warmer during the winter months January, February, and March in North America. The impacts of El Niño are mostly negative, like floods, famine, drought, but some are beneficial as mentioned in the previous point. El Niño reduces the intensity and number of Atlantic hurricanes, as well as the number of tornadoes in Canada and the US. Accompanied by a cooling of the surface waters of the eastern equatorial Pacific, cool water from the ocean depths near west coast of South America rises, warms, and flows westward across the Pacific Ocean to Southeast Asia and Australia. In North America, cold air from Alaska moves southward across western Canada and the western United States. By contrast, eastern North America becomes warmer and drier than in a non-La Niña year. La Niña produces wetter than normal conditions. Scientists cannot fully explain the causes of El Niño and La Niña, or whether there is a connection to climate change or to recent global warming.